Identifying linear functions, we're going to start with first identifying what a function is. And basically a function, when you're dealing with your x and y's, for every x there's exactly one y. What that means is if I have an equation and I plug in an x, it gives me an answer y. Okay? It gives me the solution. If I plug in the same x, I should get the same solution. If I plug in the same y, if I plug in a different x, it should give me a different solution. So for every x, there's a y. Now, the vertical line test is a way to check if a graph, okay? With checking the functions, I can just check the charts. But on using a vertical line test, I can check a graph without knowing all of the x and y coordinates. So the vertical line test, for example, all I need is that I'm going to draw a vertical line and it touches it only once. If it touches it only once, then yes, it is a function. If I put a vertical line test here, it could be anywhere. But wherever I make the vertical line, it only touches my vertical line once. So then, yes. Okay? This one, if I make a vertical line, it's going to touch it twice. So this is not a function. Because this means if I plug in this x, it can give me this y or this y as an answer. And because it gives me multiple y's for just one x, this is not a function. Okay? A linear function is a graph that makes a line. So it follows the same thing as a function, except the graph will always be a line. So there's a certain pattern that the x goes by and a certain pattern that the y goes by continuously. So in standard form, a y is ax plus by equals c. This is called standard form. Okay? All right, so an example, if I have the standard form in y equals x plus 3, I have to bring all the x's and y's to the left side and then the one without a number on the right side. So in this case, the x is on the wrong side, so I'm going to bring it here. And so it's going to be a negative x, and then since y is a positive, plus y equals 3. My a, so my exponent in front of my x is negative 1. My b is my exponent in front of y is 1, and then my c, since it equals 3, that's the one that's not connected to anything, that is 3. Okay? I can also tell a linear function is a table because the x's will go on a certain pattern and the y's will go on a certain pattern. So for example, the x's on this side, it goes plus 1, plus 1, plus 1, plus 1 every time. And the y's go, and as it goes plus 1, the y's go in the same, in a different pattern, but it's the same different pattern. So this is negative 3, negative 3, negative 3. So for every 1 you add to x, you deduct 3 from y. So that's how you can tell if a function is a linear table. Okay? And number 1, it says to tell if the points create a linear function. 0, negative 3, 4, 0, 8, 3, 12, 6, 16, 9. So what I'm going to do is I'm going to list all the x's and then list all the y's. So I'm going to go 0, negative 3, 4, 0, 8, 3, 12, 6, 16, 9. Okay, so because there's no y, like there's no x that's the same number and different y's, this is a function, a linear function. Well, actually, it's a function. We have to check if it's a linear function by seeing if there is a pattern. So 0 to 4, we add 4. We add 4, we add 4, we add 4. So x has a pattern. This is negative 3, we subtract 3, we subtract 3, subtract 3, subtract 3. Because there's a pattern on top for the x's and a pattern for the y's, this is indeed a linear function. Okay? Number 2 is to tell if the following is a linear function. If so, graph. So, let's start with this one. This x times y, a linear function, can't have that multiplication together. Okay? It has to be, remember, it has to be in the ax plus by equals c mode, and x and y can't be multiplied with each other. So because these can't be multiplied with each other, this is not a linear function. But because this can be written in the ax plus by equals c function, because here's a, b, c, I just have to rearrange it. If it can be in that function, therefore this can be a linear function. This is indeed a linear function. So in order to graph it, I have to come up with x's. You can choose. I usually stick to the same x's. We have -2, -1, 0, 1, and 2. 5 is enough. And I'm going to take these and I'm going to plug it in. Okay, I'm going to put -2. Well, this is making it a little difficult. -2 equals 2y plus 4. Let's just do 3 points right now, because there's a lot of math involved. So I'm going to subtract 4 from both sides. This gives me -6 equals 2y. Then I'm going to divide by 2. This gives me -3. This cancels out, equals y. So y is -3. I'm going to put 0 equals 2y plus 4. I'm going to subtract 4 from both sides. I'll end up with -4 equals 2y. Divide both sides by 2, I get -2 equals y. So this is -2, and then we'll do one more, which is +2, so 2 equals 2y plus 4. I'm going to subtract 4 from both sides. I end up with -2 equals 2y. Divide both sides by 2, I end up with -1. Okay? So now I'm going to graph it. -2, and then down 3. 1, 2, 3. And then I'm going to do 0, -2. And then 2, -1. So here is my graph. All right? So again, I chose these x's that I wanted to put, and I plugged it in for x in the equation right here, and then I solved for y, which gave me these. So this chart would help you then find the x and y coordinate in order for you to graph. So go ahead and try page 234, numbers 5 and 10, 234, numbers 5 and 10, and I will see you in class.